basically like the homework questions, but different. So we're gonna go through them just to see and make sure that you understand everything that we reviewed in 10.4. Does anybody want to read the question?
I'll read it for you since I'm supposed to help you. Using the height, tail length, kick force, and weight of kangaroos, we get this regression equation. Weight equals -10 plus 96 plus 43.5 plus 73.54. Identify the response and predictor variables.
Okay. Let's see. Not gonna let me do it. Okay, the first thing we need to do is identify the response and the predictor variables. But it's pretty simple. It's in the equation. Well, it is the equation, all of them. It's not letting me highlight it, but if I could highlight right now, I will highlight weight and response under the same color, and height, tail length, and kick force under the predictive variables. And this is why, because it is definition we pulled from the book. Everybody good on that?
Yes.
Okay. Number 2.
Wait, can you go back to that real quick? I'm sorry.
It's fine.
So the response is the y-intercept, and the predictor variables will be everything after that?
Yes.
Okay, thank you.
Okay. Number 2. For the regression equation given in exercise 1, the p-value is 0.019 and the adjusted r-value square value is 0.834. If we were to include an additional predictor variable of next size, the p-value becomes 0.026 and the adjusted R2 value becomes 0.873. Given that the adjusted R value squared value of 0.873 is larger than 0.834, which regression equation should be used? Explain why. Does anybody want to answer this? I mean, the answer at the bottom for everybody who don't know. You can just read it. It says adding a fourth predictor is not worth it as the gains is not greater than 0.05 as we discussed in class. Gains are calculated using 0.873 through 0.834, which in terms equals 0.039. And it's not greater than the number, so it's not worth adding a fourth predictor.
Where did we get 0.873 and 0.834 from? It's in the question, right?
Right.
Okay.
That's the regression equation for the first one. And then you add in another variable, which changes it to the 0.873, and you subtract them from each other, and then you get the number, well, the gains. And if it's greater than that number, then it's worth adding. If not, it's not. Pretty simple. Okay. This is also pretty simple. Interpret an R square, interpret each of the provided multiple coefficients determination and indicate the percent of variation that can be predicted. Does anybody want to do A?
Is it asking if a predictor variable is needed?
No, we're talking about converting the R square in A into a percentage.
So we're just turning that decimal into a percentage?
Basically, yeah.
Okay, so it would be 72.7%, right?
Yes. Anybody
Okay.
want to say B?
Would it be the same thing? We're turning it into a percentage.
Mm-hmm.
So it will be 83.4%.
Yep. Anybody want to do C?
25.2%.
Yeah, that's right. Okay. And in this paragraph pulled from the textbook, this is why we move the decimal places to the left, right, yeah. Okay, number 5, using this table, we're going to use it for number 5. Number 5 says satisfaction, identify the following. Number A would be multiple regression equation. Does anybody know how to find the multiple regression equation?
Now, Thomasina, if you remember from yesterday when we went over this, I think the next slide goes into a little bit more helpful information and then brings you back into how to solve this problem.
Yeah, I know. I was just like trying to give them a chance to do it before I put it up there. Okay, so basically on the right side, it has all of the ways that you can write the multiple regression equation. And the first one, the easiest ones to identify is StatDis, JMP, and there was one more. And the TI 83 and 84 plus calculator. And that's because they list the y-intercept and the slope in all of them, if you look at them. Okay, B, the value, does anybody know the value of the multiple coefficients of determination of R squared?
0.613.
Yes, and does anybody know the adjusted value of R2 squared? R squared, I mean, I keep saying R2 squared.
0.574.
Yes. Okay. Moving on, news source. Finding the best multiple regression equation Refer to the accompanying table. The response Y variable is the way students at Cheney University obtain their news. The predictor X variables are television, newspaper, and social media. Number 9X, if only one predictor X variable is used to predict the consumption of news stories, which single variable is best and why? First, we want to ask ourselves, what is the question asking us specifically?
Which single variable is best?
Yes,
Is
and
that
do
what
you
that
want
is?
to answer the question as well? And give us a brief explanation as to why?
I honestly don't know.
Anybody want to help her?
I'm sorry. What are we on question 9?
9, yes.
Okay.
Okay. First, she had identified that we are looking for one predictor variable. So that means we only looking at the bottom 3. Now, as we look at our R square and adjusted R square, we are supposed to look for the highest number for both. And that will be our best variable to predict the consumption.
And why is it the last 3?
Because they're all one predictor variables.
Oh, okay, I see. Okay.
So which out of the bottom 3 would be the best?
0.914.
Social media, yeah. Okay. Number 10 is asking us the same thing, but with 2 variables. So now we have to look at the next 3 up from the singles. Who can tell me out of those 3, which one is to be used to predict the consumption of news stories and why?
The first one, because it's the highest, it's the greatest number.
Which one?
TV, NSPN, social media. Oh, you said 2 predictor, right?
Yeah.
TV and social media.
Yes, and that is for the same reason for the last problem, because of the R square and adjusted R square. Okay. Number 11 says, which regression equation is best for predicting the consumption of news stories and why?
The one predictor TV.
You said what?
TV.
I'm not gonna say you're wrong, but I'm not gonna I'm gonna guide you through how to find the right answer. So it wouldn't be TV, because if we look at the next equation with 2 variables, and we have to look at the gains between the best variable, which is smartphone, which is the 0.914, and then we have to look at the best from this 2 variables and look at how much they gain. And if that gain is over 0.05, then it's better to use the two variable one. And which in this case it is, and it'll be the same thinking logically going up to the next equation with three variables, but three variables wouldn't work in this case because the gains are not better than 0.05. Do you understand that?
I do. I understand what you said. So which one would it be?
It would be TV and social media. Okay. Next, the last question here is number 12. Okay, it says, Essence Frazier, the best statistics student ever, watches 4.5 hours of television and 6.5 hours social media. What is the best predictive value of her consumption of news stories? Is that predictive value likely to be very accurate? First,
How
we need to First, we need to identify the important things in this question. First, the first important thing would be that she watches 4.5 hours of television and 6.5 hours social media. Now, the question is asking us, what's the best predictive value of consumption of news stories? And is that likely to be accurate?
do we
So first,
subtract 6.5 from 4.5?
we have to plug those numbers into the regression equation above in the chart, because
Oh, okay. I see.
she uses television and social media, so we will plug that into the equation for those predictive variables, and that equation is 4.32 plus negative 0.57 times TV plus 0.696 times social media. Does anybody want to put that in the calculator and tell me the answer? Okay, well, when you put these numbers into the equation, you get 4.32 plus negative 0.57 times 4.5 plus 0.696 times 6.5 equals 6.88.
All right, everybody. So it looks like we're at the end of the presentation. Just want to make sure the whole purpose of this presentation is to make sure that people are understanding and they get information. Now, I will put this up again. I just want to make sure, are there any questions? Is there any questions or items that people may have went over that you want to make sure that you're reiterated with? I want to make sure you have that opinion. The whole goal is to help you so that you know what to do for 10.4. So speak up now if there's something that you did not quite understand. All right, I'm checking my mic. It doesn't seem like I'm missing anybody. Seems like everybody is good and clear. All right, everybody, thank you for our presenter. Thank you guys for showing up. I will see you guys Wednesday.